Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is April 20, 2024, and the time is 2:25 a.m. Okay, I reviewed my channel, and there are some recommendations for the videos that it should be coming out from my channel. No, it's just a recommendation, and one of the recommendations is actually this involves radicals. I think this will be a great help for those young ones who are planning to take up their SAT or CAT exam, or for those who are not familiar yet with the so-called solution of radical equations. Okay, let's proceed. The title of the topic for this morning will be this is a random topic. It's a recommendation from YouTube. It should be a radical problem. The problem is solve the radical equation, and it is a topic on uh, radical equation or solving radical equations. So what I will be presenting will be a solution of a radical equation. Or it could be that I will just give you a simplification involving radicals, but I think it is more advisable that I will be giving you a problem under the so-called solution of equations involving radicals. So the problem here is solve the radical equation. If we are given the radical equation, the square root of x squared plus 3x plus 7, we got a radical sign. That's why radical, the topic is radical. And they should be equal to x plus 2. And of course, what will be the problem, or what will be the value of x equal to? The equation involves radicals, so the topic involves radical equation. Okay, let's proceed. To bring out the solution, we must have to eliminate the radical sign. That is the number one way on how to solve a radical equation if we are solving for x. To solve for x, we must have to eliminate all radical signs on the equation. Because if you cannot eliminate the radical sign, you cannot solve the problem. So to eliminate this radical sign here, the exponent here is not given, right? So it is understood this is a square root. Right? So meaning to say, if we try to replace this one by the so-called exponential equivalent, we must have to remove the radical sign. Okay? And this should be raised to 1/2. So the equivalent of the radical sign is actually, the power is actually raised to the 1/2. And to solve for x, okay, we must have to eliminate this 1/2 here. Eliminate the 1/2 or eliminate the radical sign. For the meantime, that radical sign involves just simply a square root. So to remove the exponent 1/2, there should be a number that should be multiplied by 1/2 for it to be equal to 1. So what do? We will raise both sides to the 1/2. No. We square it. Sorry for that one. What number should be multiplied to 1/2 for it to be equal to 1? It will be just be something like this. 1/2 multiplied by an unknown number, and this should be equal to 1. Okay? And that number is actually, obviously, it is 2. Right? Because a 1/2 times 2, this 2 here cancel with this. The operation is multiplication on the numerator. this is a simple 2, so actually we could cancel this one. Right? But just in case there is a plus sign here, that's another story. As long as the operation on the numerator and denominator are multiplication, we could cancel. So 1/2 times 2 is actually equal to 1. So to eliminate this 1/2 on the left hand side, we must have to raise the left hand side to the second power. Okay, or it will just be simply square both sides. Right? So it is this now. I just rewrite the left hand side in the so-called fractional exponent, same as the given original square root. Okay? And I will raise that to the second power. And they should be equal to. The right hand side is just simply x plus 2. I will raise it also to the second power. Okay? What I will do on the left, I will do it on the right. We square the left hand side, we square the right hand side. And if we try to square the left hand side, we will be using the laws of exponent. Okay? A 1/2 times 2, these 2 here cancel with this. So the resulting power of the left hand side now, it seems it just only to the first power. Right? This is 3x. After the squaring, the power of the left hand side will just be simply 1, or just simply x squared plus 3x plus 7. Of course, it is understood that the power is 1, right? And for the right hand side, we will be squaring a binomial, 2 terms, right? We square it. It will be the square of the first one. The middle term will be 2 times x times 2, which is 4x. The last part will be the square of 2, which is 4. So we square the left hand side, and we square the right hand side. Then after that, no more radical side. That's why I told you to solve for x, we must have to eliminate the radical side. Okay? As always, to solve for x, combine similar terms. To make it clearer, we will transpose the terms on the right to all to the left. So I will rewrite this one, that will be x squared. I will transpose this one to the left. This will now be negative x squared. I will rewrite 3x. Then I will transpose this 4x here to the left. It will be negative 4x. I will rewrite 7. Then I will transpose 4 to the left. That will be minus 4. Okay? So no more terms remaining on the right except the value 0. That's the so-called combining similar terms. For it to look good, right? Then try to combine similar terms after the transposition. So actually, this x squared cancel with this. 3x and minus 4x are similar terms. This is 3, this is minus 4, so it will just be simply negative 1x, or just simply negative x. Right? A 3x minus 4x will be negative x. The pure constant term is 7 minus 4, that will be plus 3. And this should be equal to 0. It's now fundamental operation. It's the so-called simplification. That's why I told you, students who are failing mathematics, they lack the so-called fundamental operations. For as long as you know the fundamental operations, okay, you will pass mathematics. Because under the fundamental operations, there are lots of what you call these topics. Then after that, of course, we are now given a linear equation, right? And to solve for x, we will maintain x on the left, it will be negative x. We transpose first 3 to the right, it will be negative 3. Okay? Then to eliminate the negative thing on both the left and right, we will enclose all the quantity, then we will multiply it by negative 1. Okay? So a negative x times negative 1 will be positive x, and a negative 3 times a negative 1 will be a positive 3. So the answer is actually x is equal to 3. Okay? The solution of the radical equation is actually x equal to 3. Let's try to check the validity of the answer. we will go back to the original radical equation. We try to place the value of x equal to 3. So this will be the square root of x, which is 3 square, plus 3 times x, which is 3, plus 7, and will it be equal to the value of x is 3 plus 2. There is a question mark over here. We are asking ourselves if the value of the left and right are the same. So if it comes out to be the same, our answer will be correct. So to verify it, we simplify. 3 squared is 9. 3 and 3 will be 9. This is plus 7. Is it equal to 3 plus 2 is 5? And if we try to take the summation of all the terms inside the radical sign, 9 plus 9 is 18 plus 7, that will be 25. Is it equal to 5? What's the square root of 25? It's either plus or minus 5, right? But we'll take the positive value. So positive 5 is equal to positive 5. Our answer is correct. For the value of x equal to negative 5, the square root, we will disregard this one. Okay? We will just use the positive sign. Okay? So positive 5 is equal to positive 5. It is true. Our answer is correct, to be equal to 3. Okay, that's it, guys. That's the problem under the so-called solution of radical equations. Okay? This is more important than by just simply simplifying radical numbers, adding radical numbers, right? So I give you a radical equation and we will solve for the unknown. Okay, good morning from Los Angeles. Professor David J. De Los Reyes.